In this present video, we will be continuing disk scheduling algorithm after FCFS and SSTF. Already FCFS and SSTF we have discussed. For just giving reminder, I will let you know that first video was disk architecture, second one was disk access time, third one was just types of disk scheduling, fourth one was FCFS and SSTF, and this is the fifth video for disk scheduling, that is we will cover scan and cscan. So in this present video we are going to two algorithm, one is scan and another one is cscan algorithm. So we first start with the scan algorithm. Scan algorithm, what it does, it just starts from one end. Like previous two algorithm we have seen, this read write head is pointing presently at 53 track number. So presently read write head is here. So according to scan algorithm, the disk arm like read write head starts at one end of the disk and moves to the other end. It first goes to one end, read write head goes to one end, like here 0 is nearby from 53, so it goes towards 0 and satisfy all the request which comes under the on the way, which comes on the way. Then it comes from 0 to other end of the disk and satisfy the request. So let us start with that. See, again we have taken the same request, same track number or cylinder number to make it clear. See here, as we have taken the same example, we can exactly find out the difference between the algorithms, how it is happening. So from 53, disk read write head will move towards 0. So towards 0 if it goes, on the way it will satisfy the request 37 and 14, then it will go to 0. Then when it is going to other end of the disk, it will be one by one satisfying the request. So here it is 65, then 67. After that, after 67 and which one is left out, that is 98. So after 98 it will go to 122, then 124. From there it will go to 183. See, 183 we have the last request to the extreme end of the disk, like extreme end is here 199. So towards 199 the last one is 183. So again if it another request comes, disk head read write head should go to 199, then it will turn back and it will satisfy the request. So according to scan disk scheduling, first thing to remember is where your read write head is currently pointing. If it is given very fine, start from that, go to one end which is nearby. You could have gone to that end also. It is also not probably mistake. It can go to any end, but preferably it should go to that end which is near to the current location. So it goes to 0. While going to 0, 37 and 14 request is satisfied. It has touched to 0. Then it has again taken the turn other to the other side and keep on satisfying the request. Now the question is, what is the use? See here, if you want to calculate the distance traversed, you can just subtract this from this from this, you can get the distance. But you may feel, no, why it has to touch 0? It would have could have taken turn back from here itself and it would have gone to 65 directly from 14. It could have been like from here to here, but it has not happened. There is an algorithm afterwards we'll discuss where it will not go and touch the extreme end of the disk. But what is the use of doing that? Use is, see, this request we have taken some request which has already come. So the moment we are starting our disk scheduling, at that moment these all requests have already entered. We are not considering any dynamic request. Dynamic request means what? When the read write head is at 14th location, at that moment, let's say after 67, one more request is there, that is track number 4. So when the read write head is at 14th location, at that moment or before that, if one more request come that is to be read or written at location 4, so that request also could have satisfied if the disk blindly moves to 0. So it is very helpful if continuously request is coming. Otherwise what will happen, you see, we have taken a set of requests here. So after 14 going here, you may feel that 14 plus 14 here, going and coming back to 14 is a waste of time. But if you are considering real life situation and dynamic request, in that case what will happen, maybe when the disk head is at this point, there may be one request lower to 14. So instead of disk moves to this and comes back this to 4, it will be too much time to satisfy the request for 4, whereas only in the 10 unit of move it could have satisfied then and there at that time. Okay, so that is the reason in scan algorithm practically it doesn't happen, but the reason being taking that algorithm is that, okay, it can satisfy any dynamic request. Present situation, it is a static case, so it is a loss of traveling, distance is increasing. But the algorithm hopefully you all have understood. Start from the current position. One more thing is, if current position is not mentioned, can be started from 0 or can be started from the last location, that is 199. Okay, hope it is clear. We'll shift to CScan now.